So, ladies and gentlemen, ready for the last session now. It's a long day. It's like a very long and interesting and very tasteful buffet or menu. And at the very end is the dessert. And I think this poster presentation, which I will show now, is there. So, distinguished guests, colleagues, friends of metrology, it's a true honor to welcome you today to this special ceremony celebrating the incredible breadth and impact of modern measurement science. And this year's collection of online posters brings together more than 386 contributions from every region of the world, which is a remarkable showcase of innovation, collaboration, and scientific ambition. I will briefly go through these 386. No, I won't. I will talk about the 9 topics. We begin with topic number 1, which is the SI units and fundamental metrology. These 74 posters take us to the very foundations of science, exploring how Josephson junctions, quantum Hall arrays, single electron pumps are shaping the future of electrical standards. You see how graphene, optical electron pumps, optical techniques, and the Kibble balance continue to improve the realization of the units. Trust in science and industry begins with a solid metrological foundation. So topic 2 turns our attention to environment and climate change, which we also heard earlier today. Here, 45 posters show how measurement science quietly empowers global efforts to monitor pollution, track climate signals, and support clean transitions. Some from airborne ammonia to black carbon in the Arctic, from microplastics to low-cost sensors, metrology is enabling evidence-based climate action. Without trusted data, no sustainable future, actually. Topic 3 is on health and life sciences and presents a powerful message. Precision saves lives. With 61 contributions, this topic spans digital PCR, radiotherapy, dosimetry, RNA standards, AI-supported diagnostics. It shows how measurement supports everything from vaccines and biomarkers to MRI calibration and ventilator accuracy. So metrology steps beyond the lab, helping clinicians deliver safer, more effective and better care around the world. Topic 4, we turn to safe food and water, a field where trust is non-negotiable. These 38 posters cover emerging challenges such as PFAS, allergens, and nanoscale plastics, alongside classic concerns like mercury or arsenic. From yerba mate in Latin America to milk standards in Europe and seafood from Asia, the message is clear. Food and water safety relies on robust, globally harmonized measurement systems. Topic 5 explores the engine of our sustainable future, energy. Across 22 contributions, we see the role of metrology in electric vehicle infrastructure, hydrogen production, renewable integration, and battery health. Green hydrogen, photovoltaic calibration, and smart grids are just a few of the exciting areas where metrology is building trust in a cleaner, smarter energy system. Topic 6, industry and advanced manufacturing. We dive into the technologies powering tomorrow's economy. These posters reveal how metrology enhances precision in semiconductor fabrication, 3D printing, e-waste recycling, protein engineering, atomic step heights, to UV imaging. Takeaway is simple. Without measurement, there is no quality, no innovation, and no progress. Topic 7 brings us into the digital age under the banner of digital transformation, AI, I also had to say that word, and systems metrology. These posters showcase digital calibration certificates, remote audits, AI-driven or supported tools transforming everything from radiotherapy, time services. And the SI digital framework is not just an aspiration, it's happening now, and it's reshaping the very fabric of how we measure, trust, and collaborate. Then we arrive at topic 8, quantum technologies, where metrology meets the frontier of physics. Contributions span quantum resistance standards, single photon detectors, and superconducting qubits. Quantum breakthrough needs metrological rigor to be trusted, to give trust in quantum systems for communication, navigation, or computing, just to mention a few. And finally, topic 9, new opportunities for metrology captures the spirit of exploration. These posters range from nanobots to sustainable electronics, to heritage conservation and planetary monitoring. They show how our field is evolving, not just responding to global needs, but anticipating them, inspiring the next generation. In conclusion, these 9 topics represent not just scientific progress, but the expanding role of metrology in shaping a more just, sustainable, and resilient world. Whether in the lab, the clinic, the factory, or the forest, measurement matters. And I said 9 topics, but there will be 10 presentations now, because we also have the young metrologist presentation, actually. So I'm looking very much forward to it. Thank you so much to all contributors, reviewers, and mentors who made this extraordinary collection possible. Let's now celebrate the global metrology community and the future we are building together. Merci, thank you, and let the ceremony commence. So, Edgar.
Thank you so much for this generous introduction and for setting the tone of what promised to be a truly meaningful session. Friends and colleagues, good afternoon. Sorry, it's quite late. We are before the cocktail. I know it will be hot. I'm Edgar, as you can see in the picture, and I had the honor of helping coordinating this poster session on the behalf of the BIPM. It is a real joy to welcome you here to celebrate the 150 years of the Meter Convention and the BIPM, and the people and the passion and the progress that have brought us here to this historic milestone. Now, before we dive into each remarkable poster, you will notice that every topic will begin with a short introduction slide. This slide will present the topic, and just below that, the name of all the lead authors whose dedication, curiosity, and expertise made these contributions possible. So I will invite you to take a moment to give these contributions the recognitions they deserve, these 386, and with a round of applause for their hard work, their vision, and their collaboration. Not yet. And to the authors who are here with us today, if you feel comfortable, each time you see your name on the screen, please wake up and receive this, that this is our way to acknowledge not just your effort, but also the teams and co-authors behind the scene who have helped make this work shine. What you will see in these posters is nothing short of inspiring. You will see scientific depth, technical excellence, and a spirit of collaboration that remind us why this community is so fundamental. Thank you, and let's enjoy the presentations. The presentation. Thank you. So let's start with topic 1, SI units and fundamental metrology. This topic brings together, as Hans just said, 74 posters at the forefront of measurement science. You will find work on every topic. Josephson junctions and quantum Hall arrays, 2 efforts to redefine the Kelvin and the second. We will see how cable balance is still evolving. Isotope radios deepen our understanding of mass, and technologies like single electron pumps and graphene are shaping the future of the ampere. I think I wasn't clear, because if you see your name, you need to stand up and we need to clap. Please, to topic 1. I see one, don't be shy. Whether it is refractometry, timekeeping, or new ways to define voltage and current, this collection shows how fundamental metrology drives innovation, ensures global consistency, and supports the technologies we rely every day on. These aren't just technical achievements. They are the foundation of trust in science, industry, and in our daily lives. Now it is my pleasure to introduce the first speaker, Dorothy Mringie. Dorothy is the author of the outstanding poster for this topic. She's a graduate of the Master of Science in Applied Optics program at the National Institute of Optics and Lasers in the Multimedia University of Kenya. In her studies, she focused on line profile analysis of the 6p states in rubidium using double and triple resonance spectroscopy. Today, she works at the State Department for Trade in the Weights and Measurement Department, where she hopes to apply laser-based techniques for precision measurements. Dorothy is also passionate about inspiring the next generation of scientists, especially those from underserved backgrounds. That is very important. Her research has been supported by the Max Planck Institute for Light, and her scientific journey continues through active global collaboration. Please join me to welcome Dorothy.
Thank you. Once upon a time, when you landed in France, the time on your phone automatically updated to the local time here. Why is that? Atomic clocks. Now, let's travel back in time, yeah, and find out where it all begins. When an atom interacts, in this case, rubidium, interacts with laser through a process called spectroscopy, the electrons move from one energy level to another. Now, the absorbed or emitted light is usually in form of patterns unique to the structure, more like a fingerprint. And in spectroscopy, this is known as line profile analysis. Now, from the energy levels split from the fine to the hyperfine structures, and the spacings in between the hyperfine structures are, we call them the hyperfine intervals, and that is our interest in measurement. And what is the problem? One would ask. The problem is the rubidium has very closely spaced hyperfine intervals that are difficult to measure. Now, several techniques have been used to generate the line profile, and one of them is the double resonance, where the drawback is that electrons or atoms move to the lower ground state level, not coupled by any laser, known as a dark state. And therefore, it is difficult to resolve this line profile. Hence, we used the triple resonance spectroscopy, where we introduced another laser in order to repump the atoms that were lost. Therefore, in the results, we could see that the line profile were well generated, were well resolved, and henceforth, we were able to measure them up to close to the natural line width of the rubidium. Therefore, this makes rubidium an active, and it makes rubidium a candidate for a good candidate for atomic clocks and quantum metrology. Thank you.
Thank you very much. Excellent. I think we have a question from Hans. No, it's okay.
Thank you. Just one quick question for you now. How does your research using triple resonance spectroscopy in rubidium contribute to the advancement of quantum metrology and the mission of the BIPM? It's a rather broad question, but...
Okay, thank you for that question. In this research, we enhance precise spectral lines. We enhance spectral line measurements. And in these measurements, they can be used for quantum metrology and also for atomic clocks, which brings Kenya, which is a developing country, into the conversation of SI units now and not playing catch-up. Thank you.
Thank you very much, Dorothy. Thank you, excellent. Welcome to topic 2. Nobody stand up? No authors? Joel, you can stand up. We have many of my colleagues who have contributed to this. Please. In these 45 posters, you will discover how metrology is quite shaping global efforts to understand, mitigate, and adapt to our changing planet. From improving the traceability of CO2 isotope radius and ozone standards, to developing reference materials for microplastics, aerosol, and PFAS, these works tackle pollution and environmental issues with scientific rigor. You will find innovations in environmental monitoring, from airborne particle matter to ammonia, from the Arctic cryosphere measurements to acoustic biodiversity in the Amazon, one of the favorites. Cutting-edge projects are featured, including the use of satellite-based background calibration, laser-based ozone sensing, and small-scale tech for rapid tracking, as Dolores mentioned it, low-cost sensors. Together, these contributions highlight a vital role of metrology in protecting the ecosystem, as was mentioned in the session of Robert, enabling clean energy transition, supporting climate action through accurate and trusted measurements. And we are very pleased to highlight two outstanding posters selected under this topic. The first one is titled Using Miniaturized Technology to Rapid and Accurate Monitoring Environmental Pollution, by Dr. Jackie Jun, Assistant Research at the National Institute of China. While she is unfortunately unable to join us in person today, her excellent work is proudly displayed alongside to the other posters, and we warmly invite you to explore it. And please, let's give her an applause for being chosen. Our second selected poster is from Dr. Kai Fuu Ming. Dr. Kai is a principal scientist at the National Metrology Center, part of the Singapore's INC for Science, Technology, and Research. He earned his PhD from the University of California, and is specialized in gas metrology, stable isotopes, atmospheric chemistry, and environmental science. His recent work focused on ensuring the quality of low-carbon fuel, advancing air quality measurement techniques, and developing cost-effective gas sensors for safety and environmental monitoring. Dr. Kai plays an active role in the international collaboration, notably as former chair of the APMP focus group on climate change and clean air, and actively in projects with the International Atomic Energy Agency. Please welcome Dr. Kai.
Thanks, very honored to be here. So I think in the morning we learned about climate change. We learned about this is important. We need to reduce the carbon emission for the atmosphere. So we also learned that there's a way we need to monitor that. This is important. But also, when we talk about that, we also need to learn that what are the methods to reduce the carbon. So we know solar panels, we install a solar panel, we have the wind farm, we try to use renewable energy. The other one I also want to introduce is low carbon fuels. Low carbon fuels is the fuels have produced less carbon or emission into the atmosphere compared to traditional fossil fuel. So this one is important according to International Energy Agency. So this is quite important because especially for the transportation sector. So for example, so you have the long distance ship from Europe to Asia, or you have the aviation. It is quite impossible to use like battery, big battery, install that. So low carbon fuels, this is one of the key promising fuels to apply. So when we look at that, so we want to adopt that. But what are the challenges we are facing? So there are challenges. This is new energy sources, so high cost initiative. You need to have the new technology. And also you think about what are the limited methods to verify whether this is low carbon fuel or not. So this is important, especially say in the future, you want to buy the low carbon fuel, you pay extra money. So right now the process probably look at the digital information saying this is a process to show that this is low carbon fuel, pay more to me. But as metrology, we think about measurement, how measurement we can contribute on this part. So we think about whether there's a way we can provide evidence, scientific evidence to show that this we do have the evidence, not only for the digital process, and we look at the process, but we also look at the evidence to look at it. So then isotope measurement is one of the methods we can consider is quite powerful to look at the sources. And then they can tell you the fingerprint and also look at to try to comply with the legal compliances. So then we look at isotope measurement. Isotope may have high potential, but we also think about what are the challenges. We see this is an opportunity, but we do have the challenges. So when we look at low carbon fields, there are multiple components. There are some matrices like Sanli and mentioned in the morning. So there are challenges for handling those isotope measurements. And also, we look at what are the new technology used. There can be mass spec, isotope ratio, mass spectrometer, and also we see the new challenges or new opportunity to use the laser-based optical system. So they provide more portable and system they can measure more. And the other one we think about that important is metrological traceability. And this is important, and also international collaboration. So we see this is like different party. BIPM have been playing important role like providing traceability, and also we work with other agencies like IAEA, International Atomic Energy Agency. So this is like the custodian and the reference material. So we do need to have work together how to harmonize what are the standard to be used and what are the systematic process to apply. And for people work together, we not only work together for metrology institute, but need to look at the legal metrology or standardization party to implement so those are process. And not only that, so once we get the data, we need to build up the database, more data, and just now we learned FAIR, we need to share, and people learn that. And also, you know, this is some reliable data to be used. And this one, also to show that we like in Singapore, we do have the promoting international collaboration. We work with IAEA, and also this is the provide the regional expert center for training analysis. So this is promoting what are the methods to be used and people to use it, promote on that. So eventually what we want to see is we want to have better quality assurance. And also we want to target on what are the sources, where they are coming from. And two more things to highlight. So we say we want to adopt the low carbon fuels, we want to prevent greenwashing. So we have the evidence for measurement, and eventually we want a fair and transparent trade. Thanks.
Thank you.
Please. Yes, we have time for a small question, Dolores.
Yes, thank you.
Yes.
There is something that I am curious about, and I think that it could be the interest of the audience, and it's also linked to the panel session we have this morning on climate. So maybe could you tell us something about how much does the transportation sector contribute to the CO2 emissions?
Yeah, it's a good question. So when we talk about contribution, so when transportation important is about 21 to 24%. So when we look at that is transportation, we have a car, internal transportation sector, they have a car, and route here, we see a lot of fossil fuel cars still using. But we see this is possible then converted to electrical car. But there are two sectors that are important, like shipping and aviation. It covers about 10% it's about 10% each. So this is a sector we do see that aviation they're increasing and shipping is increasing. So this is the sector need to address how to mitigate and then reduce the carbon. Thanks.
Thank you very much. Topic 3, health and life science. In this topic, we celebrate the powerful alliance between metrology and medicine. From innovations in dosimetry for radiotherapy, flash therapy, I still don't see anyone stand up. Who are the authors there? Well, because, thank you for your contributions. To groundbreaking work in digital PCR, RNA enumeration, these 61 posters reflect how precise measurement transforms lives. We see the rise of biometrology supporting diagnostics from neurodegenerative disease, infection threats, and the standardization of biomarkers, genomic material, and novel proteins. Whether it is advancing pathology tools, calibration, MRI scans, or ensuring ventilation accuracy, this work drives clinical confidence, global harmonization, and patient safety. So, automated systems, quantum technologies, and machine learning, metrology is moving from the lab bench to the bedside, shaping the future of personalized, preventive, and precision healthcare. Please dive into these online posters. Don't forget, they are still there. They will still be there. Measurement science is making healthcare more accurate, equitable, and effective for all. Now, it is my pleasure to introduce Dr. Chiara Giangrande, a biomedical researcher with a strong background in biotechnology, proteomics, and mass spectrometry. She currently works at the National Metrology Institute of France, LNE, in Paris, developing reference materials, standardized measurement procedures for clinical relevant biomarkers, particularly in neurodegenerative disease, cardiovascular conditions, and diabetes. Chiara obtained her master and PhD in biotechnology from University of Naples, Italy, and after completing her PhD, she moved to France to join the École supérieure de la physique et de la chimie industrielle, for our colleagues French. In 2017, Chiara joined LNA and has notably contributed to the standardization of tau protein assay in cerebrospinal, finally I said correctly, fluid, a key step toward to improve diagnostic Alzheimer's disease. She coordinates the European initiative NeuroBioStan, promoting international collaboration to improve diagnostic reliability in neurodegenerative disease biomarkers. Please join me to welcome Chiara.
So thanks for the introduction. Let me to introduce this European project. So NeuroBioStan is a European consortium funded under the European Partnership on Metrology, 𝐏𝐿SCOL 2022. And this project aims to standardize biomarkers for neurodegenerative diseases by developing SI-traceable reference measurement procedures and certified reference materials. Why is this important? Because neurodegenerative diseases are a worldwide emergency. And behind any clinical test, there are persons, patients, family members, caregivers that are waiting for a response. And yet, we are still fighting variability in how we measure these conditions. And this is particularly important because now we are assisting to the availability of new therapies for these conditions, particularly for Alzheimer's disease. NeuroBioStans gather together NMI, DIs, clinicians, academics, and industry partners under the umbrella of the 𝐦𝐸𝐿𝐬𝐢 working group. And our work is divided into 3 technical work packages. The first work package on phosphorylated tau, p-tau. This biomarker is particularly important for Alzheimer's disease. And we are working on the development of a SI-traceable reference measurement procedure based on isotopic dilution mass spectrometry to measure this biomarker in plasma. This method will be used to certify the concentration of this biomarker in certified reference material. The second work package is on another biomarker, neurofilament light chain. This biomarker is a more general biomarker of neuroaxonal damage. And we are also working on an isotopic dilution mass spectrometry method, and this will be used again to certify the reference materials. We are also working on a clinical LCMS method that will be used to study the correlation of mass spectrometry to immunoassays. The third work package is on an emerging biomarker, glial fibrillary acidic protein, GFAP, and we are working on the development of a reference measurement procedure. We are also working on structural approaches because these conditions are also known as protein proteinopathies. So the structure of the protein is also involved in the mechanism of the pathology. So, in conclusion, NeuroBioStand is working on providing accurate tools in blood to measure these conditions. And I'm really happy to coordinate these efforts. And we hope that we will have in the future the possibility to deal with this pathology not as a mystery, but as a challenge that we are equipped to meet. Thank you.
Please, with a question of CIPM.
Thank you very much for your work and for your poster. Congratulations. How can the BIPM and the global metrology community further support the standardization of clinical biomarkers for neurodegenerative diseases in order to assist the IVD industry in developing reliable diagnostic tests?
Thank you for this nice question. The BIPM and the global metrology community are already working on this. And I want to cite the work of the 𝐏𝐴𝐴 protein analysis working group in improving measurement capabilities for protein biomarkers. In addition to this, I want to cite the fact that many NMIs are already involved in international organizations like the IFCC and 𝐦𝐨𝐬𝐭, and these organizations are really important to engage with the stakeholders from industry. So we have many collaboration with the IVD providers, and we hope that in the future we can also have some biopharma companies on board, especially for the new developments in immunotherapies for diseases like Alzheimer's disease.
Thank you. Topic 4, safe food and water. Any stand-up people? Well, anyway, we will, please join me. Yeah, officer, I see one. Highlights a vital message. Metrology is at the heart of global safety. The 38 contributions addressed a broad range of challenges, from emerging contaminants like PFAS, perchlorates, to long-standing concerns such as heavy metals in fish and mercury. The community demonstrated a major progress in developing advanced methods, creating certified reference materials, and organizing international comparison to ensure traceable and accurate measurements. Contributions included certified reference material for food matrices such as yerba mate, rice, cacao, and seafood, as well as work on nanoscale plastic, food allergens, stomach cell counting in milk, and novel proteins, for example, from insects. These efforts aim to protect consumers, support fair trade, strengthen regional economic resilience, and advance the transition toward a circular economy. Decisions showcase a global collaboration and innovation with impactful work presented from East Africa to Philippines, Uruguay, and South Korea. All together demonstrate that the future of food and water safety is being shaped by rigorous and forward-looking measurement science. Now it is my pleasure to introduce Dr. Adrian Pegoraro, a research officer in the Nanoscale Measurement Group, part of the Metrology Research Center at the National Research Council of Canada. He received his PhD from Queen's University and completed postdoctoral studies at Harvard University. During his PhD, he led the development of new light sources for multimodal optical microscopy, enabling label-free and chemical-specific detection of molecules. His postdoctoral work focused on using soft matter physics to study the cell and tissue mechanics, with emphasis on the role of mesoscale physics forces in the development of cancer. In his current role, Dr. Pegoraro is developing new tools for characterization, identification, fabrication of nanoscale materials using both classical and quantum light sources. Please welcome Dr. Pegoraro.
So for most people, when you say there's a problem with plastic waste, they think of garbage on a beach, plastic floating in the ocean. But what happens to that plastic? It sits in the sun, it's exposed to temperature changes, UV, waves, and it breaks down. It becomes microscale and then nanoscale. And the nanoscale plastic is everywhere. It's in our water, it's in our food, and it's in our bodies. But how worried should we be about this? When people ask me, how much nanoscale plastic is out there? I don't know. We don't have a reliable detection method for it yet. Does it cause any harm to us? I don't know. We haven't been able to figure out how to measure that in a really quantitative way. And so to answer those questions, we set out to make a nanoscale plastic reference material so that we can start to figure out these detection limits. So how do we do that? We take an ultra-short laser, so femtosecond laser, we focus it onto a piece of plastic and water. What this does is it directly breaks the bond, so it ionizes the plastic in a very small volume without depositing heat. So we don't melt and we don't burn the plastic. The idea being that we should be able to make this nanoscale materials into still plastic. So how do we go about verifying what we made? Well, we can use IR spectroscopy, so that's basically looking at the chemical structure. And when we look at it, we see it looks more or less like the plastic we started with. It is modified. We ionized it, we did something to it. But it turns out that those modifications are actually what we see in environmental plastic. So you take plastic that's been sitting on a beach for 60 years, and you say, how is it different from pristine plastic? It has extra OH and carbonyl groups, and that's what we find in the plastic that we make. So it seems to match what we find in environmental plastics. All right, that's a good start. Now I said we want nanoscale. How do we confirm the size? There's several different techniques for doing that. We use atomic force microscopy. So we can measure the 3D morphology, and we find that yes, it is nanoscale. It's also asymmetric, and it's highly irregular. Again, this is what we find when we look at environmental plastics. Because they're formed from fragmentation, they are not nice, uniform things. So then, one of the big questions is, does it in any way mimic what we see in the environment in terms of how it interacts with biology? Well, that's a little harder to answer. So there are correlational studies where if you have more plastic in, let's say, your arterial plaques or in your blood, there's pro-inflammatory responses. So we know that from humans, we know that from animal studies. But if we give animals, say, polystyrene beads, or cells, polystyrene beads, most of the time it doesn't do anything. Now, polystyrene beads are spherical, and they're chemically pure. So what happens if we say, let's take our plastics that we made, and we give them to cells and organoids? What we find is that it produces pro-inflammatory responses, kind of what we see in the human body. And it also can reduce cell viability. So we think that taken together, these materials will be able to set limits of detection using different chemical and physical techniques and act as a positive control for starting to understand the biological effects of nanoplastic exposure. Thank you.
Thank you very much. I think we have a question.
Hey, congratulations. Very nice work. I have two parts to my question. So first one is about the technique. How do you think you can scale it up? Or what's the future for this technique? And the second one is about the CRMs. How do you plan to take it forward? Do you have a reference material producer, or how do you plan to make it available to the public?
So for scaling up, one of the things that's really nice about the multiphoton ionization is it's pretty material agnostic. So we've used it for 3 different types of plastics already, and from the literature, it actually works for pretty much any dielectric material. So we think we can, and the femtosecond lasers are becoming much more powerful, and so we can actually start to scale this up to making liters of material at a time, so that we can start to make a lot of it. And the way to distribute it is, so we're actually going to start making it available to the community. So we've already made enough that we're starting to do that. And the goal is to start working with groups like VAMAS and with the CIPM topical group in nano and microplastics, share it widely, get other people to start using it, characterizing it, and then both for physical and biological purposes, so we can really start to get a handle on this problem. Thank you.
Thank you very much. Any volunteers? Topic 5, stand up. Well, anyway, yeah. Thank you for representing topic 5. So the poster on topic 5 illustrates how metrology continues to drive innovation and trust in the global energy transition. From power grids to hydrogen fuel, the 22 contributions reflect both technological advancements and the collective ambition to meet sustainability goals. Posters explore the modernization of primary standards for AC and DC power, the metrological challenge of electric vehicle charging infrastructure, a problem in all cities, and the definition uncertainty in the emerging DC grids. Green hydrogen emerged as a strong theme with developments in field test standards, fuel cell materials, and traceable methods for hydrogen and ammonia analysis. Other highlights included, of course, photovoltaic technology, lithium-ion battery health, that is at the state of the art at this moment for recycling, and in situ reference electrodes for hydrogen production, all showing how deeply measurement science is embedded in renewable energy systems. These posters underscore a clear message. As we build a cleaner future, measurement science provides the backbone. With collaborative efforts from Europe to Asia and Pacific, and innovation ranging from spectroscopy standards to advanced thermal materials, the metrology community is shaping the path toward reliable, traceable, and sustainable energy solutions. Now, it is my pleasure to introduce Dr. Ojai Ongrai, the author of the outstanding poster for this topic. Dr. Ojai has been deeply engaged in the Asia and Pacific Metrology Program, APMP, Energy Efficiency Focus Group, for nearly a decade. She has coordinated the group in 2016, served as vice chair in 2021, and now she is the new chair in 2025. Her leadership has driven major initiatives focused on the role of metrology in supporting the sustainable energy across the Asian Pacific region. Dr. Ojai holds a PhD from the Advanced Technology Institute at the University of Surrey, UK. Please join me to congratulate Dr. Ojai.
All right. สวัสดีค่ะ With our precise measurement, energy efficiencies, hydrogen adoption, and renewables, which important for climate action, cannot scale globally. Don't you agree that? It's an honor to be here to share how collaborate metrology efforts in Asia Pacific are driving the sustainable energy transition. APMP EEFG we plays a crucial role in strengthening the methodological foundation for energy across the technical field, from thermal energy, the electricity, to renewable energy, PV solar, and energy flow measurements. As you can see here, it's not only one technical field can fulfill the energy. For example, in green building, you measure the speed of our air, you measure the temperature, humidity. It's not only one field can fulfill. We are actively support the challenge for emerging technology, EV, smart grid, and hydrogen energy. This ensures that metrology advances at the speed of energy innovation. Collaboration is the heart of our mission. We work closely with national metrology institutes, developing NMI, industry leader, and energy stakeholders to harmonize the measurement practice and build the capacity across the Asia Pacific. We work like this since 2016, over nearly 10 years, and through the target workshop, symposium, and technical meeting, we bridge the methodological gap and strengthen the measurement infrastructure for energy transition. In summary, APMP EEFG is not just advancing energy methodology, we are actively collaboration, working together, expanding regional partnerships, and integrating advanced measurement technique to ensure an equitable access to reliable, efficient energy worldwide. And by the way, thank you for your energy attention, and ขอบคุณค่ะ
I think we have a question.
Thank you very much, Dr. Ongrai, for this introduction of this horizontal activity. So you're doing this, you're clearly recognizing that the energy transition, and you were referring to it, we should not only bring together different institutes, but also different technical disciplines. And that's really very challenging. So thank you for this initiative and leading it. My question is, this is a regional activity. What if we would scale it up to the international activity? So suppose we have an international BIPM activity similar to like the environment and the data science that we heard earlier today. How could that support, what should we do at the international BIPM level to support activities like you?
Okay, by my experience at NIMT Thailand, we work a lot on regional, and when we work for a long time, we are work Flores in APMP, but we still difficulty to get the budget to maintain our standard and whatever. What we would like the BIPM to do is fostering the international collaboration. It's like we need policy maker know, our government know that measurement need to be recognition. Even because in Asia country is different. Some countries ready for hydrogen, but for Thailand, energy efficiency is enough important. And also, we need to prepare because we in the climate action policy world, so we do need to do hydrogen in next 5 year or 10 year time. It's good we have collaboration that we learn from Chris, from NMIJ, but if we have BIPM to fostering the international collaboration and let policymakers, stakeholders know that metrology need to be recognition and be in the policy of every country that we can improve our work together. Thank you.
Thank you very much. Any candidates? Topic 6, metrology for industry and advanced manufacturing. Please. We have 4. Thank you. Thank you. This topic shows that measurement science is the foundation of modern industry. From boosting the efficiency of electric machines for low-carbon future, as we just saw with Dr. K, to enabling accurate fuel volume measurements, these online posters reveal where traceability, precision, and innovation intersect. We see cutting-edge developments in atomic scale step height measurements, for example, UV metrology for 3D printing, as Hans just mentioned it, and the standardization of glare assessment for high dynamic range imaging. Posters also highlight metrology supports the semiconductor production, heat treatment reliability, and micro-volume calibration. And metrology's role doesn't stop there. It extends to recycling critical elements from e-waste to characterize the novel design of proteins for new material development. Whether it is through X-ray computer tomography, electro-optics power sensing, or precision calibration, one message is clear. Industrial progress and sustainability are powered by accurate, reliable measurement science. This is metrology in action, driving innovation, right? Enabling trade and building a resilient manufacturing future. Now, it is my pleasure to introduce Dr. Sarah Hill, Principal Scientist for the core metrology in the Inorganic Analysis Group at 𝐦𝐨𝐬𝐿. She works within the UK's National Measurement Laboratory, which supports 𝐦𝐨𝐬𝐿's role as the designated institute for chemical and bioanalytical measurements. Her work centers on high accurate calibration techniques, particularly isotope dilution analysis combined with inductive coupled plasma mass spectrometry to develop reference materials and methods and produce ASI traceable certified reference materials. Beyond the lab, she contributes to the field as a writer for the Atomic Spectrometry Update Review in the Journal of Analytical Atomic Spectroscopy, and she currently serves as a chair of the Atomic Spectroscopy Group at the Royal Society of Chemistry. Please welcome Dr. Sarah Hill.
Thank you very much, and it really is a pleasure to be here as part of this event and to highlight the work that was undertaken in the Metrocycle EU project, which brought together the metrology community with the e-waste recycling industry, with academia and research institutes to tackle this particular challenge. And ultimately, this is a 3-year project in 3 minutes, so it is quite a whistle-stop tour of the highlights. But first of all, technology critical elements, or TCEs. These are elements which are essential for modern technologies, such as mobile phones and clean energy initiatives, And TCEs are unusual elements. They have unique properties that mean they are difficult to replace. Elements such as indium, gallium, neodymium, as well as precious metals like platinum and gold. They cannot be replaced easily, so we need a sustainable source of these elements in order to maintain our position and to develop new technologies. One way to ensure this is through recycling of e-waste, as annually millions of tons of e-waste are disposed of each year. Therefore, being able to extract TCEs represents a sustainable resource. Furthermore, it also works to support the European Union's circular economy agenda and also the UN Sustainability Development Goals 7 for cost-effective and clean energy, for 11 in terms of sustainable cities and communities, and 12 for responsible consumption and production. So test of my memory here. We focused on 15 elements, so 15 TCEs, and we concentrated on 3 materials as the starting point: printed circuit boards, LEDs, light-emitting diodes, and lithium-ion batteries. Now, we had a number of challenges to overcome, the first being sampling. How do we get from tons to grams? So we worked on sampling strategies to ensure we were getting representative samples. The next challenge was material preparation, and we had to use a variety of machinery, such as shredding, cutting, and milling equipment in order to break down this complicated material. And this resulted in a number of broken instrument parts from this process, as this waste is incredibly difficult to process. However, we were successful in obtaining suitable materials for these 3 samples. We then focused on the analytical part, as the industry needs reliable, validated analytical methods. But there's a lack of these available, plus the lack of reference materials to enable the industry to do this. The partners of the project looked at a multitude of analytical techniques and calibration approaches, which included routine industry techniques, as well as the high accuracy methods that we would use to characterize the reference materials. We learned a lot during this process, and ultimately we were able to put together some guidance documents and share with the industry. And we also highlighted some outstanding issues, such as the use of portable XRF equipment, which is common in industry, so some further work is still required. We organized an interlaboratory comparison with industry partners to test the state of the art and using that guidance. And we were really happy to see that overall, and across the 2 materials that we looked at, the general agreement was within plus or minus 20% of the consensus mean. And we felt this was a really good achievement for the first time and the first sort of type of this study. So in summary, we also looked at the training. We also provided training documentation, guidance documentation, produced tools to support industry with uncertainty calculations, as this is still an area that industry needs support with, as well as, I think, the most key thing we obtained from this project, which is 3 real-life relevant reference materials that will continue to support the industry on this complicated and challenging topic. Thank you.
Very much, excellent. I think we have a question from the CIPM. Victoria.
So, Sarah, thank you to you and the consortium. This was a super interesting poster. So you guys were funded again for another 3 years. What is the next kind of pressing metrology issue that you'd want to focus on for these technologies or these elements?
Part of the issue with these elements is that they're unusual, so there isn't much research on them. And this kind of then applies into the environment and into bioavailability. So this is kind of one of the other areas to consider. What happens in the environment? What kind of transformations? How mobile are they? Is there any biological activity? But I also think that we also need to consider bigger and things such as end-of-life solar panels, wind turbine motors, and electric vehicles. But I think really one of the key things, and I think actually kind of a key theme that's come out from the last few days has been collaboration. And I think more collaboration with material scientists, with physical chemists, with engineers, who are working on these like next generation technology products, and to start that collaboration at an earlier stage to understand what are the future challenges that we might be facing, and to really achieve that sustainability goal number 12 of the responsible production as well as the consumption. Thank you.
Thank you very much. Bravo. Topic 7. Thank you. Topic 7, digital transformation, artificial intelligence, and system metrology is redefining the boundaries of measurement science. From the integration of digital calibration certificates and smart data models to the application of artificial intelligence in diagnostic imaging and radiotherapy audits, metrology is rapidly evolving, as we saw this morning, to the 21st century. We are witnessing today the rise of system metrology, digital twins in mass and ionizing radiation, and the development of intelligent tools programmed in Python and R, all around, always talking about Python and R now, to enhance proficiency testing and remote calibrations, right? This new paradigm is transforming healthcare, time and frequency services, and industrial diagnostics. And it is also reinforcing global quality infrastructure through the initiatives like SI Digital Framework, Quality Infrastructure Digital QID. Together, these innovations are driving trust, scalability, and precision in our increasing data-driven world, as we saw this morning. Metrology is supporting digital transformation. Now, it is my pleasure to introduce Dr. Daniel Schwabe. Dr. Schwabe holds a master in mathematics from the Humboldt University in Berlin and earned his PhD in theoretical biophysics at the Max Delbrück Center for Molecular Medicine. Since 2021, he has served as a coordinator for the digital medicine at PTB. He's actively involved in the TEF Health, a major European Union-funded initiative focused on testing and validating artificial intelligence solutions in healthcare. Very important. Daniel's research centers on the quality assurance of the artificial intelligence in medicine with a strong focus on the data quality. Use it in machine learning applications. Very important, as we learned this morning. To support this, his team recently introduced the metric framework, a systematic approach to assess the quality of machine learning data, use it in clinical and diagnostic tools. Please welcome Daniel.
Yeah, thank you so much for the nice introduction and the invitation. I sensed a little bit of AI fatigue in the room throughout the day, unfortunately. I think actually we are only beginning, so we really have work to be done. As you know, artificial intelligence solutions are being adopted into almost all major application areas. Unfortunately, comprehension and thus quality assurance of the technology is lacking behind. To improve on this issue, PTB got involved into the TEF Health project, led by Charité and involving over 50 partners across the European Union. As we also heard already in the last session, data quality dictates the behavior of AI. Therefore, evaluating the quality of both the training and the test data is a crucial piece of the puzzle on the path to quality assurance of trustworthy AI. To this end, PTB has performed a large literature review involving over 5,000 publications in order to distill the knowledge on data quality frameworks and combine it with the perspective of machine learning in medicine into what we call the metric framework. This is what you see in the center of the poster, divided into 5 clusters of characteristics. This is a systematic way of evaluating the suitability of the data set for a given machine learning task. Very important, we're trying to evaluate the fit for purpose part, as we heard also today in the panel before. Doing so reduces biases, improves robustness, and facilitates interpretability, and thus lays the foundation for trustworthy AI in medicine. We believe that the metric framework has a wide variety of potential applications, ranging from the validation of training data during audits to constructing reference data, as well as designing test data. Harmonizing such evaluations is crucial and might accelerate both the development as well as the approval of solutions and products in AI in medicine. To reinforce this view, we've also compared with the EU AI Act and their data requirements. And we find that the data requirements of the AI Act distinctly and comprehensively map to the metric framework. Therefore, utilizing the metric framework also shows compliance with the EU AI Act. Currently, we're in the process of equipping metrics to our data quality characteristics in order to implement them into a tool for automatic data quality evaluation. Furthermore, we are quantifying the effect that data quality characteristics have on the downstream system characteristics, such as predictive performance, the uncertainty, fairness, and robustness. We hope this supports the development of so-called golden data sets, if you want, new standard for the field of machine learning. Also, we hope that we can develop seals of approval for data sets that might be given out by neutral organizations such as metrology institutes in the future to support the development of trustworthy and quality-assured AI solutions. Thank you.
Excellent. Thank you very much, Daniel. I think we have a question from Hector.
Okay, congratulations for the selection of your poster, and thank you for the clear presentation. I have two questions. One is you presented a framework with a special focus on medicine, so my question is why you submitted this poster to the digital transformation section and not to the health section? And the second one is, do you see applications beyond medicine for this framework, for instance, in industrial AI applications?
Yeah, thank you so much. Indeed, our results are focused on the healthcare domain, but I believe that the processes and the methods that we use are much more important and have a broader importance for other domains as well. We see more and more measurements being based on networks of sensors, and this, together with the technologies such as AI, highlight really new challenges for metrology and in complex systems. Systems metrology is a new field in metrology, and we believe that our approaches can be a starting point for this. So we believe that this is more important in this field here. Obviously, we have been already thinking about whether we can transform our current considerations from the healthcare domain to other domains, and this is part of active research. A lot of the things that we have collected here and distilled can be, of course, applied to other domains, although each domain has its special requirements. So this has to be carefully mapped, but a lot of things can be used, yes.
Thank you very much. I've been kindly reminded that we are a little bit late, so we will hurry up, okay? Very fast. Who is there in topic 8? Metrology for quantum technologies. Ah, excellent. Thank you very much. Quantum technologies are reshaping the frontier of science, and metrology is at the heart of this revolution. From quantum communications and entangled states to superconducting qubits and quantum gyroscopes, the need of precise, trustable, and standardized measurement has never been more urgent, right? Initiatives like MetricQ, S-France, and NMIQ are fast-tracking the integration of quantum tools by building robust reference framework. Key significant developments include quantum resistance standards using the anomalous Hall effect, improved detection efficiency for single photon detectors, laser stabilization for advanced quantum systems, validation of quantum random numbers generators, and next generation of nanoscale thermometry. Whatever driving secure communications, next-gen sensors, or quantum computing, metrology provides the pillar for trust, performance, and scalability in this rapid emerging field. In this short future of quantum, can start with metrology. So now it is my pleasure to introduce Dr. Martina Marzano. Dr. Marzano received her master's degree and PhD in physics from the University of Torino and Polytechnic di Torino. In collaboration with INRIM, her doctoral research focused on developing new devices and methods for quantum resistance and impedance metrology. Between 2018 and 2019, she was a guest researcher at NIST and in 2021 at PTB. Since 2022, she has been a researcher in the Quantum Metrology and Nanotechnology Division of INRIM, following a postdoctoral period in the same group. Her current research is dedicated to advancing measurement methods and devices in the field of resistance, impedance, and small current metrology, contributing to the precision and trust we need for the next generation of quantum technologies. Please welcome Dr. Marzano.
So thanks for the nice presentation, introduction. So this presentation is about potential new primary resistance standards based on quantum anomalous Hall effect in topological insulator without an external magnetic fields. So just briefly introducing primary resistance standards in the new SI, they can be obtained from on the base of quantum Hall effect in terms of the von Klitzing constant that is defined as fixed and without uncertainty. Quantum Hall effect measurements needs very high magnetic fields and low temperature to be measured. In figure 1.1, this parameter depends on the devices that you are using. So in figure 1.1, you can see that the quantized resistance the quantized resistance is obtained in the traditionally employed gallium arsenide devices is obtained a very high magnetic field and low temperatures. But nowadays, many NMIs are moving to graphene primary resistance standards that require lower magnetic fields and higher temperatures. Section 2 presents the quantum anomalous Hall effect as a easier realization of the ohm. And so from plot 2.1, we can see as once magnetized, this kind of devices maintain the resistance quantization when the magnetic field is removed. And this is a very nice thing. In fact, greater knowledge of quantum anomalous Hall effect devices is essential to accelerate the development of a quantum electrical metrology toolbox, which can combine a Josephson voltage standard together with a primary resistance standard in the same cryostat for the universal adoption of quantum electrical SI standards. The project QAMET, Quantum Anomalous Hall Effect Materials and Devices for Metrology, will grow, characterize, and evaluate thin films and devices fabricated from them, leading to a detailed metrological assessment of these devices. So unfortunately for now, this potential primary resistance standard cannot be still employed because these devices for now require very low temperature and very low currents to be measured. So in section 3, the partners of this project are presented. There are several NMIs and universities of all the world. And in section 4, you can find the main goals, objectives of the project divided, organized in work packages, and part of the infrastructures of the partners that will be employed during the project. Section 5 presents the most recent results of the 𝐏𝐭𝐫 project. In particular, in figure 5.1 is presented a technique to increase the current that can flow through the devices, while in figure 5.2, it is presented the first metrological assessment of quantum anomalous Hall effect resistance standard in terms of the relative deviation from the quantized resistance. So more details can be found in the reference cited in the poster. And to conclude, in section 6, you can find the link to follow our project and to remain updated on the main results. Thank you.
Thank you very much. Very nice. Thank you very much. I think we have a very short question.
Very short question, and great talk and great piece of work. So quantum Hall effect has been used in electrical metrology for a long time. How will the anomalous quantum Hall effect transform the field in the future?
Okay, thanks for the question. So nowadays, the measurement traceability is mainly based on artifact standards that are moved from calibration points such as an NMIs to measurement to user points such as calibration laboratories or industries. But thanks to the fact that quantum anomalous Hall effect can be measured without the application of a magnetic field, it can be integrated with other quantum standards. And these in this framework, the 𝐏𝐭𝐫 project will provide a route for the development of a robust and self-calibrated quantum voltmeter that is the holy grail of the electrical metrology, I think. Thanks.
Thank you very much. We are nearly at the end. Topic 9. Do we have any? Yes, please. Thank you. Topic 9, new opportunities for metrology highlights how metrology is evolving to meet the challenges of the 21st century. From atomic clocks to nanobots redefining quality control, this session of posters online showcase innovations that explain and expand metrology's reach into new scientific, industrial, and societal domains, where it is advancing sustainable electronic through memory stores, improving heritage conservation, or enabling traceability in quantum and nanoscale systems. The posters demonstrate that metrology is not just about precision, it is about impact, right? Wake up, yeah, we are nearly there. We see new technologies shaping future capabilities, while international cooperation attempting to ensure that progress benefits all globally. That's very important. Whether it is enhancing satellite geolocalization, analyzing nanomaterials, or inspiring future generation of metrologists, these contributions demonstrate how metrology is not just responding to global needs, it is driving progress in precision, sustainability, and international partnership. Now it is my pleasure to introduce Elizabeth Benham, who serves as the NIST metric program leader, and a passionate advocate for the international system of units in the United States. Her efforts are critical to realizing national policy goals to advance the SI as a preferred measurement system for trade and commerce, and to reinforce national innovation and competitiveness in the global markets. Through her leadership, the NIST metric program plays a vital role in supporting national measurement policy, enhancing professional development in metrology. Elizabeth is committed to raising professional metrology standards through target training development aligned with industrial needs. Her work underscores the importance of the SI in fostering scientific literacy, and her dynamic approach combines policy implementation, public engagement, professional training, and science, technology, engineering, and mathematics education promotion. Please welcome Elizabeth.
Well, I will say it's a pleasure to be here, and I'm going to give a call to action. I need everybody's help to take advantage of this huge opportunity, and that is developing the next generation of measurement scientists. So as we look towards the future, we need to recognize that we're facing many challenges, and one of those is, being proficient at using the SI and having a high level of scientific literacy. So what does that mean? Why is that important? Well, having this high level of functionality with proficiency and competence with the SI and scientific literacy means that our future professionals are able to interpret, to communicate, to apply, to analyze using the SI when they communicate measurement results and make impactful decisions. So what we have is a challenge with educators that may not have had a formal preparation in education and teaching the SI or understanding the elements of measurement science. So some of those challenges are, complex theoretical topics like the fundamental constants, out-of-date textbooks, inconsistent use of the SI in those textbooks, lack of hands-on, engaging, fun, laboratory and classroom activities that are available in the public domain. So how can we overcome those challenges? Well, let's think about the pipeline and where do we need to start. So think about, in the poster we present 4 categories starting at age 5 and 5 years increments. So when a young person is 5, the world is their oyster, they're waiting to be inspired. And that's when we need to create those aha moments. That's where we need to spark the joy of measurement, the skills that solving a problem and measuring the world around it. Why are measurements important to me? That's what we need to look at for the student. We also need to think about the teacher and enabling them to spark that joy. As the student moves through the STEM pipeline, science, technology, engineering, and mathematics, oftentimes they will go on that pathway, but we have other students that maybe they'll go into the trades, maybe they will go into arts and music, maybe they will go into business, maybe they'll be entrepreneurs, and all of those things. We have to recognize that measurements are important in their daily lives, and at some point, we may come full circle where those individuals are in fact our future leaders. They're our future decision makers as well. So what we need to think about is developing these resources at each level of that career pathway. So how can we do that? There's a lot of resources I'd love to share with you and invite you to come by our poster that NIST has developed at each of these levels. And thank you very much.
We are short of time. I think we have time for a short question.
Thank you and congratulations for this very nice work. We all know that education is a very important opportunity. This is a very important need and an important challenge for metrology and for society. So I have a short question about the prospects in this domain. What steps can be taken to scale the SI educational resources global?
Thank you for that question. I think what comes to mind are 3 primary steps. First of all, come together as a metrology community, nationally, regionally, internationally, to make a commitment to prioritize SI education and promote it. Secondly, I think coming together at a regional level makes sense because we can set up communities of practice where we can effectively share best practices, lessons learned. And I think it's very important that at the regional level, in order for a classroom teacher to bring an activity or lesson plan into their class, it needs to align with local education standards. Third, we have a professional development challenge. We have to take a two-pronged approach. We have pre-service teachers that are in the university. That's where we need to prepare them as they go out into the workforce. These are new teachers, and equip them with measurement science principles and those tools to take into the classroom. We also need to bridge the gap with current educators that are, very experienced and give them the tools that they need. And I hope all of you will reflect, I know you have at least one educator that was important in your life that inspired you. And that person, when you invest in a teacher, we get amazing return on investment. They will teach thousands of students across their career. They will not only mentor their peers, new teachers, they will mentor their teams. They will cross interdisciplinary boundaries within their school districts. So, thinking about those inspiring teachers, we want them to have the confidence to stand in their classroom and teach the SI. They're going to impact, students that are going to be our citizens. They're going to be our consumers. They're going to be our future decision makers and our leaders. They're going to be our innovators and our future metrologists. And I would just challenge you, I want to hear your ideas. I want to see how we can initiate that and make that commitment together as a community. It's my pleasure to be here today, and please stop by our poster. We'll talk about it a little more.
Thank you very much. Thank you very much. So remember, all the author of the posters will be downstairs, so you can comment on that. Thank you very much, Elizabeth. Thank you. So, now, it's nearly over. As Dolores said, I will take 5 minutes of your time. The 27th General Conference on Weights and Measurements held in 2022 marked the launch of an inspiring initiative, right? The Young Metrologists 2050 Plus vision. This mandate sparked the global consultation with young metrologists, a vibrant, forward-looking exploration of the future of the metrology. More than 380 young professionals took part in this journey. Some of them might be in this room, at least one. Through workshops, debates, and interviews, they explored the trends, technologies, and challenges that will shape our field in 2050 and beyond. And what did we discover? That young metrologists are stepping up as leaders, bringing fresh ideas, new energy, and genuine passion for impact. They are not just prepared to face the future, they are ready to lead the transformation of metrology, ensuring that it stays relevant, responsive, and resilient, and keeping all the old generations with them as well, don't worry. And today, we are truly honored to hear from one of these bright minds, a representative of the next generation of metrological leaders. It is my pleasure to introduce Cristiano Alfredo Paredes Cardona. This I can pronounce perfectly, because Cristian is a chemical metrologist at the Instituto Nacional de Metrología de Colombia. There, he leads the internal working group focused on certified reference materials and electrochemical measurement methods. His current work is centered on developing digital tools to manage metrological information in line with the FAIR principles, whatever it means. In 2022, Cristian received the CIPM Early Career Metrology Award and was a future contributor to the BIPM Young Metrologist Vision 2050 Plus initiative. Please join me to welcome Christian.
Thank you. It is a great honor to be here, and it's a pleasure. Thank you, you all. I would like you to imagine a world in which flavors and odors, smells, are properties which nowadays are difficult to measure, but that will someday become something that we could assess in an objective manner to an acceptable level of accuracy. And I want you to imagine the doors that it will open for us regarding matters such as environmental monitoring and food quality assessment. And it will for sure bring many benefits to our stakeholder community. And this is the door that perceptual metrology opens for us. Perceptual metrology, it's also known as soft metrology. It deals with characteristics of bodies, substances, and phenomena that relate to how they are perceived by living beings, mostly humans. If you remember some of the keynotes yesterday, in 𝐏𝐸𝐵 we are forced to consider the identity of the substances of our measurements when we are trying to measure them. When we regard to flavors and smells and odors, we often deal with dozens of substances, hundreds and sometimes thousands of them, which are not that easy to individualize. So it is more convenient to us to consider them as a whole. And as a whole, they open the door for them to be to realize what is the impact they have on living beings and in humans. And we have several examples of how those benefits are impacting our life nowadays in several places. We can use bioelectrochemical sensor arrays that are commercially known as electronic noses and electronic mouths. That give a non-specific response to these bunches of substances that produce flavors and smells, and are currently being used to monitor some quality of food, some characteristics of food quality. And there are another examples of how perceptual metrology is helping us to improve the services that we provide to our stakeholder community, and it is mainly based on the combination of biological and electrical devices. For example, the use of bivalve mollusks to monitor water pollution in cities. We can use these bivalve mollusks to filter the water, and it can be seen as these clams and mussels like tasting it. When the water is not tasty enough, they will react by closing their shells, which will imply that something is wrong with the water, and it will typically mean that the water is polluted. And another way to use these biological electrical devices is by a technique named electroantenography, which uses two electrodes connected to an insect's antennae, which will transduct their olfactory response to volatile molecules into electrical signals that we can measure, and it will help us to assess how we can protect our insects, which are pretty important for our food, as they are important in the pollination. These new approaches to tackle some of the things that we need to work on pushes the boundaries of what can be solved within metrology, and it will bring us many benefits. For example, we can use such principles to ensure pleasant olfactory places for all people and all times and everywhere. Thank you very much.
Thank you very much, Christian. I will invite Hans to do a final remark of our incredible session. Thank you very much.
So I will round off there isn't much I can say to improve on this one, I must admit. So to be very brief, first of all, I mentioned the 386 posters. They are all available on the BIPM website, so I strongly encourage you to go there and visit. There's a lot of extremely good material available for you. And then a big thank you to these super presenters. It was really fascinating to be here with you and listen to you. Yeah.